Hi everyone, welcome back to the VoLTE End-to-End training campaign. In today's session, we are going to cover the part related to the mobile terminating end-to-end call flow, and we'll just try to address the differences compared to the mobile end-to-end call flow. And this part will be covering 3 points. The first one related to high-level view of the mobile terminating call scenarios. For example, the user, whenever he's going to receive the call, the mobile terminating, he might be in idle mode or connected mode. So we'll explain from high level point of view what will be the network or user behavior in this current kind scenarios, either in idle or connected. Then we'll go through the end-to-end call flow and we'll explore in details about the main messages for the paging and something called downlink data notification. I will explain this part directly from the Wireshark. I will show you what is the messages context which we have it and what is the explanation for it, and also what kind of scenarios failures we might see in case of mobile terminating. And then within this part also we'll be covering some information, good, very interesting and good information about the 4G paging in general. So let's move forward. Okay, this is a high level view of the UE states in case if the user is in idle mode or connected mode when is ever going to receive a call. So we'll go through both of them. But let me first explain something called ECM state. Actually, this UE ECM state, actually ECM refers or stands for EBS connection management. And this, like it's being tell us, this ECM state tell us whether there is an active connection between the UE and the BC or the core network or not, whether we have an active connection or not. What it means by active connection? Actually, active connection means that whether we have active EBS peer context or not. For example, the EBS peer, which is mainly for the default peer, for example, XI 5 and XI 1, whether it's being active or not. And in general, the EBS peer actually consists of three sub tunnels or peers. As you know, there is, if you remember, between the, let me show you. For example, as you know, between the UE side and the inode B, there is a radio bearer, right? And between the inode B and the MME, there is S1 connection, right? And this is, we call it like tunnel endpoint. And there is also another connection between the MME serving gateway, then between the serving gateway and the packet gateway. All the connection will be released in case of if you are in ECM idle mode, except the connection between the serving gateway and packet gateway, which is S5 S8 interface, which is a GTB tunnel between both of them. This will be retained all the time because will be used in case in idle mode to notify the user. This will be explained in more details and whenever you go to the end-to-end call flow. So the ECM in general, as I mentioned, just it tells us whether there is an active connection between the UE and the core network or not. This is the main important point about the ECM state. And in general, the MME is responsible to track this kind of ECM state. Whenever the user move to the idle mode, the MME will know. So it will consider the user in ECM state. So, and it will notify also the other entities and it will start releasing the related interfaces or connection as we just mentioned. So now let's go through the both scenarios to just see what we'll have in case of the user is in connected or active. So I assume the user already in connected mode and he starts receiving the call. So in this case means that PCI 5 already active and the user already having PCI 5. So he can directly receive the invite, the SIP invite. He can directly receive the SIP invite message from the PC or proxy CSCF, right? It can be directly send the same invite message. So once he directly receive, because he have PCI 5 active, so he can receive all the SIP signaling as we mentioned in the previous sessions. So once he receive, he will be able to directly to reply with this 180 session, which as we explained before, including the SDP offer and this answer. And this SDP offer just telling the mobile originating that this is my supported codecs to start the negotiation about the codecs which is going to be agreed between or negotiated between both users. Then what's this being done? Then the network, once the network receive the 183 session, it will just start the procedures or process for the to establish a dedicated bearer for the mobile terminating call. So this is a straightforward because the user is in active state or the connected mode, so he already have PCI 5, so he can directly receive the SEP invite. What about if the user is in idle mode? User in idle mode means that there is no bearer between the radio bearer between the UE and the inode B, and also there is no only S5, S8 interface is being there. S5, S8 interface, which is between the serving gateway and packet gateway. Actually, what will happen here? Because the user in idle mode, so the network will initiate something called initiate service request procedures or process. What it means by this, we'll explain this part in more detail now. This means the network will start now trying to notify the user that he have a call. So the first thing we'll do, as you can see, this is the overall entities which we have it. As you can see here there is a tunnel This tunnel, in case of idle mode, which is between serving gateway and packet gateway, which we call S5, S8 interface, and this is the tunnel between them, it's retained active all the time, and also the peer context is being retained within the packet gateway and serving gateway. We just need to activate now the connection between the MME serving gateway and the MME and the BTS and the users, and also between the serving gateway and the user. This is what we need to do through the paging process or this network initiated service request. So what will happen? The first thing we'll do that the BCSF will send something called a payload application, or in general the save invite message. It will forward the BCSF proxy CSF will serve for the save invite message to the packet gateway. So the packet gateway will start understand that there is a data need to be sent to the user. So it will send this downlink data directly to the serving gateway, as mentioned here. It will be sending the downlink data, and as I mentioned, the tunnel already activated, so it can send directly the data without no problem about that one. But now, what will happen? The serving gateway doesn't have any connection with the user, so it cannot forward this 7 byte. It cannot forward until there is a connection or PCI 5 being established, so it can forward this 7 byte message. So this data will be buffered within the serving gateway. It will buffer this data until it having an active connection, so it will proceed with the 7 byte. So what will do? The serving gateway will send something called DDN, which is stands for downlink data notification. It will send it to the MME, and within this message, including some information related to the API, EBS peer identity. We'll show this in the next slide for the end-to-end code flow using Wireshark. Then directly the MME will send the paging, right, for the each unit B within the tracking area update. Actually, this paging information, the paging information, this will be sent for each tracking area, for each, unit B within the tracking area. For example, assume that you have one tracking area update and consists of 10 unit Bs. So the paging will be forwarded for all of them, and unit B will start forwarding this paging until the user using the rate. And we'll explain, find his paging, the user. Once the user finds his paging, he will reply, and this will now establish a connection between the serving gateway and the user. And now the buffer data can be forwarded, which is now having this signaling and media period being recovered. And now the serving gateway can forward the same invite. And after that, the EUE can continue with the process normally compared after the same invite. Once you receive, will just complete with the process. So now, next slide, we'll explain the details about the messages contents and what kind of failure scenarios we might face in case of mobile-terminated. So now let's move forward to see what we have. So this is actually the overall entities which we have it. Let me first explain to you. As you know, this is all the entities, UE, NOD, BMME, and serving gateway, and sometimes we call it SPC. Actually, first of all, just let's recall what kind of interface is being used, or interface to connect between both of them. And then we have something called protocol. It's like let's say, the language which is being used to communicate between these different entities. So we have RX and GX, RX between BCRF and CSF, proxy CSF, and GX between packet gateway and BCRF, and this is used diameter protocol. Then we have GTP v2. This is v2 usually used for the control plane, and this is the protocol used to communicate between packet gateway, serving gateway, and MME and serving gateway, and this is having interfaces. So now let's go through what we're expecting from the traces. So as you know, this is for the terminating code. So the proxy CSA for first thing will receive the same invite, right, from originating. Once it's received the same invite here, it will just directly forward this same invite to the BCRF and packet gateway. So they will understand that there is now ongoing traffic, but they know that the user already in idle mode because there is no connection S1 and S11. This kind of interfaces or tunnels between both of them is being released, and even the radio bearer. So they won't like to activate this one. So what will happen? The packet gateway, it's know that there is data coming already from the SEB invite, and BCRF already notified through this SEB invite that there is a data already incoming for this particular user. So it will send this data to the serving gateway called downlink data, just notifying there is incoming data. So the thing that, as you mentioned in the previous slide, serving gateway will buffer this kind of data until it having the connection being established. But after that, the serving gateway will forward this downlink data, but it will just notify the MME that there is already ongoing data is coming, and within this downlink notification, we have something called EBI. And EBI, this is just telling them about the EBI or EBS peer identity, for example, identity 6, which means we'd like to establish now the XI5 and the all related default peers as well. So this will notify about that part. Then The MME should reply with downlink data acknowledgement, not acknowledgement actually. Forget about this acknowledgement in case if the UE and the inode B processed the paging domain. This should not come after the inode B confirmed that user already replied. So once the MME received this downlink data notification, the MME will forward this paging message to the inode B. But just again to stress into this point, the MME actually initiate the paging procedures by sending paging message, okay, to each inode B that serve belonging to the tracking area, to the cells blocking the tracking area. For example, assume that you have 100 cells or 10 inode B as we mentioned before. So this paging message will be forwarded to all the inode Bs which is falling within the tracking area update, which within this paging information. This is we're showing now from the Wireshark. This is the information within the paging information. We have something called UI identity index. We have something called UE paging, which include the STMs, the MMID, and we have the CN domain, whether it's CS or PS network, and for sure because it's VoLTE, so it's operating over PS, but in case of CS fallback, for example, it will operate over CS domain. Then we have the tracking area update list, and this is considering having the MCC and MC and BLMN and tracking area update. So it's know the tracking area update, so it forward the paging to all the InnoDs within this particular tracking area update. Then after that, the InnoD will process or will move or forward this paging to all the each InnoD will forward the paging for all UEs under that particular InnoD until the UE who having his, for example, it's usually the paging using this paging RNTI. Once the user detect the paging, he will just start initiating now after something called RSC connection. We'll show that part now shortly. So next step, actually, I would like to show you the context of each of this message from Wireshark. I will open it now, but before doing that, I would like just to explain quick information and very interesting information before jumping to the Wireshark part. Actually, here I would like to explain some information which will be very important in your troubleshooting and even optimization if you're would like to do some optimization even from RAN side or the MME side to improve the paging in general, success rate or paging like the delay or latency or whatever. As you can see here, for example, in this figure, this is the MME. It's already forward the S1 AP paging, and once it's forward the paging to the inode B, the inode B now the enemy will start timer called T3413, and actually this is a supervision timer for the paging procedures, paging process. And actually, the MME can reattempt this paging process procedures in general if this timer expired before it receive any confirmation or before it receive this particular message from the UE, from the inode. For example, if this process, if the user didn't receive the paging for some problems, for example, user is out of coverage or whatever, so within this particular time, if he didn't receive a reply or feedback from inode B, so this time will be expired, so it can again initiate a new paging. This is actually the main idea about that part. And actually, usually the implementation of this T3413 is you can say it's different from one vendor to another, but it's kind of similar. So this is the first thing. So I just again need to recall some important information about how the InnoD will know, for example, the information about this particular users and what is, for example, his frame number, what is his UI identity and so on. For example, if you remember here, we mentioned that we have UI identity index, right? This is actually used by the InnoD to calculate the paging frame, the PF, right? The paging frame. How doing that? Doing that through using a formula, which is this formula. Actually, it's will directly being sent to the user, directly being calculated already. And it's actually equal UEMZ, the MC mod 1024. So this is based on that part. The InnoD will understand what is the paging frame for this particular user. Then the UE paging will tell them this is the STMC for this particular user, and this is the MME ID for this particular user. And CN domain will just tell them this is the paging, and as we mentioned, the tracking area update already the inode will know the paging will be forwarded for each tracking area update. And once the paging is being sent to the UEs, there is a DRX cycle. For example, the user will woke up each this paging occasion, right? Just to start decoding the BDCH. So this is also parameter. If you optimize it, for example, decrease the woke up scenarios, so you might get even better delay or even better success rate for the paging. So the user will not miss the paging is being sent from the inode B to the EU. So this is another scenario. So what kind of failure scenarios you might see, right? And Mobile-Terminated in case of the user in idle mode. It actually we can say it's classified into three scenarios, right? The first part that maybe this paging DRX cycle is very large, it might prevent some users from detecting the paging, even giving a delay or failures, or even the tracking area update itself is being defined wrongly. So if it's defined wrong with this init b, so it will forward the paging to a wrong tracking area, so the user cannot receive, or for example, the user already out of coverage. This is the three common scenarios which you might face it in general. But here, just to explain, once the user receives the paging, he will just start the random access process. Then he will start sending this RSU connection and initiate something called a service request, as mentioned here, which through initiating you initial message, and he will initiate this kind of service request, which is saying that this is bullet terminating. I would like to initiate now. I would like to start getting my context or the XI5 being established. So it will just sending this particular message. So now let me open the Wireshark to show you what kind of information we can see directly from Wireshark. And this is just will be something interesting in case if you're using Wireshark to know how to check. So now, as you can see, this is a Wireshark. As you can see here, this is a source and destination. Usually you'll find IP here, but you can convert it into, if you have the IPs, you can convert it into the entity or node name. So as you can see, the first message here is called downlink data notification, right? Which is this particular message being sent from serving gateway to the MIME as shown here. So this message, as we mentioned before, it should include the EBI, right? Which is called EBS Pure Identity. So let's explore and see what we have within this message. I'm just telling you only about the BCP identity. So let's view the packet details. Okay, as you can see here, within this packet details, as you can see here, we have the message type first, which is downlink data notification. And we have the tunnel endpoint for this particular message, which is being the tunnel endpoint for the MME itself. This is the tunnel endpoint. Then we have this EBS Pure identity, which is EBS Pure 6. And already the node B know this is equivalent to which, for example, quality of service or which KSI. So if you right click here and you expand this subtrees for that part, you'll find just information of this EBS Pure down here. This is telling him this is my EBS Pure identity, and then it's showing some information about the allocation retention priority. So this is downlink notification. You can see now the init B starts sending, the MME starts sending once received this downlink notification, the paging, and you'll see that paging is being repeated a lot. Why? Because as we mentioned, it will send the paging for each init B within the tracking area updates. Assume you have 10 tracking area update, 10 init B within the tracking area update. So it will send for all of them. So for all of them. So what kind of information you have here in the BIS paging? If you click this one, as we mentioned before here, you will find this S1 AP application protocol. And this one, it's telling them that this is, let me click here. This is actually the information which you have at this part. This is the paging. This is process. It's a procedure. It's procedure codes ID paging. Within the paging, we have this information which we already highlighted here. This is above here, as you can see. First one, UI identity index value, which just defining the frame number where the user would be served. Then U paging identity, which having the STMZ. If you open this part, for example, let's export, expand subtrees, it will having the STMZ and it will have the MME code as well. Then you will have the CN domain. If you export this part as well, you will have this one, for example, tell him this is a PS network, right? Because this is VoLTE. In case of CS fallback, it will be CS. Then the tracking area update list, it will having the tracking area update, PLMN, and MC and MCC. This is actually all the information which being mentioned here. So once the init B found that this user replied, if you go down here, more, if you go down and down, yes, if you can, let's first hide this part, like the details. See now, downlink notification being acknowledgement. It's being replied here. This means that this paging, this message should come after the paging being received or responded. This means that the user already found replied, the user being replied. So downlink notification acknowledged this message being sent. So after that part here, the user now should start initiating the call, which is, as you can see, if you go up here, you can see that the user now start initiating an initial message service request, say being sent it from the init beta MME, because from the user side there is ongoing RSC connection and even the RATch process, and this is he will send service request, and this service request it will be piggybacked, as we mentioned in the previous session, within the initial UE message, and this is will including a very important information which already explained in the previous session. So once as I mentioned, once the paging being received now, what will happen? Just exact the same as we explained in the previous session. You can refer to the previous session if you would like to get the details for all these messages already explained in the previous session for the mobile originating. These will be exactly the same. User just will be sending the RSU connection process. It will send this initial UE message, which you just showed, including service request, and all this kind of information will continue same as we have mentioned before. And actually, that's it for today's session. I just would like to highlight one last part. I will just upload this documents or the documents after we finish all the training session to the I will add it to the video description so you can get or use these documents for your reference. And here I just added one more slide I already explained in the previous related to the network initiated service request. And in general, service requests can be initiated even by the user or by the network. By the network in case of terminating calls, by the user instead of mobile originating call. And this is just the service request. So I will upload again this information or this slides once we finish the complete training sessions. And next session will be about the VoLTE features, and I believe you will like it a lot. So that's it for today's session. I hope if you like the content, please share it and like the content and comment. Please share your feedback and see you in the next session. Thank you very much.